Chapter 9, Section 8 in the 7th grade note-taking guide is entitled Pythagorean Theorem. Here we're supposed to use the Pythagorean theorem to find the length of a side of a right triangle. That's a good descriptor because that's what the Pythagorean theorem does, and that's the only thing the Pythagorean theorem does. When we're working with the Pythagorean theorem, we're using squares and square roots, which is why it logically follows where we've been. It's a nice logical order since that's what we just learned. Pythagorean theorem, what it is, it's a formula for finding the third side of a right triangle, assuming you know the other two. That's really all you can do with the Pythagorean theorem. There is another way to find sides of a right triangle given a very specific type of right triangle, two very specific types, a 45, 45, 90 and a 30, 60, 90. That's talking about the angle degrees of the interior angles of the triangle there. But here, that's all we have here to find find the third side given two of the three is the Pythagorean theorem. And the Pythagorean theorem, the nice thing about it compared to that 30, 60, 90, 45, 45, 90 deal is it works for every right triangle. Doesn't matter what the other two angles happen to be, it works all the time. So let's look at the components here that are involved with the formula. A leg. That's in a right triangle, one of the sides that includes the right angle. And the hypotenuse is the other part of the formula. In a right triangle, that's the side opposite the right angle. And then what they give us is the definition of the theorem, which is really setting up the formula. It says in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. In other words, a squared plus b squared equals c squared. What the formula says here is if you take the lengths of the legs, the two sides that make the right angle, take each of those and square them and then add them up, it's going to be the same thing as the hypotenuse squared. Every single time, no question, as long as it's a right triangle. And since we're only talking about right triangles here, if you see something else today, you automatically know they can't be doing Pythagorean theorem. So, let's look at the question in 1a here. Now, as you can see, this triangle is already labeled for us. We're finding C. So that means I know that I'm finding the hypotenuse here. Which means these other two sides have to be the legs, because that's all we can have in a right triangle as far as the theorem goes. Now, how do we know what's what here? Well, that's actually pretty simple. The legs of the triangle are the two sides that make the right angle. So they actually make that L shape. So that's going to be my 12 and 16 making the L shape. Which means this other side here, the one that's across from the right angle as they described it, as you can see by my arrow, it is indeed, the one that's across from the right angle there is the hypotenuse. So what the formula says is I'm going to take those two legs, 12 and 16, and square them and then add them up. 12 squared is 144, 16 squared is 256. And I'm going to add those up and get 400. And that's going to be the same as the hypotenuse squared, which is why they wrote c squared here. Now, the problem is, I don't want to know what the hypotenuse squared is. If we look back up here at this triangle, I'm not finding the hypotenuse squared, I'm just finding the hypotenuse. So, this is being solved for the hypotenuse squared, but I just want to get back to the hypotenuse. Well, the way we fix that issue is we take the square root, because you already know from what we saw yesterday that squares and square roots are opposites of each other. So that if they're opposites of each other, they'll cancel each other out. So if I have c squared and I take the square root of it, the square and the square root are going to end up canceling each other out, which is how I'm going to get to my solution here. So go ahead and take the square root now. Because you're solving an equation, yes, that's really what you're doing here. You have to do it to both sides of the equal sign. Just like if we were solving a subtraction equation, you would add something to both sides of the equal sign. So here, take the square root all the way across. Square root of 400 is 20. The length of the hypotenuse then must be 20 centimeters. One thing you have to note here is the hypotenuse, because we're always adding the other two up and squaring them, the hypotenuse always has to be the biggest side. So for some reason when you solve it, if your hypotenuse isn't your largest side, something is clearly wrong, because c in the formula, the hypotenuse, is always going to be the biggest number that's yielded when you're working with the formula.